So far, we've done a lot of work with the soluble parts of the wood ash, but now I'm going to take a little bit of time and look at the insoluble part of the ash, uh, what's left over after we've extracted all the solubles. And as I'm sure you know, wood ash just appears as a gray powder. This has been cleaned up as much as I could and washed and allowed to dry. And research says that this is almost certainly calcium carbonate, which is insoluble. But calcium carbonate by itself is not gray. Of course, it's white. So it'd be nice if this could be cleaned up further. So even though I don't have it on video, I did take some of the insoluble ash and I roasted it just like I did the soluble. And I don't know if this is going to help at all, but I'm going to put this in some water and see if it will help me separate, and maybe I can get it cleaner. I don't know how this is going to go, but I'm going to give it a try. So I'll just take some water, put some in this beaker. Drop in a stir bar. And then start adding this insoluble ash. Hopefully when it settles, it'll separate out into layers, and maybe the carbon will be separate. So I don't know. Well, I can't see how that was in any way useful. No, I didn't detect any kind of separation. It doesn't look any cleaner, really. So I'm going to just decant off as much water as possible. Maybe try something else. Okay, well, since I can't clean it up this way, what I have here is some hydrochloric acid. It should just convert it to calcium chloride, which is soluble, and at least I'll be able to separate it, but it won't be carbonate anymore. It'll just be interesting to watch the reaction. let's see if we can filter this and clean this up now. Okay, so after a couple of hours, that thing finally got done. I shut down the vacuum. Actually, quite a bit of solid left. So, I don't know, maybe I could have added more acid. I don't know. But I'm gonna dry this out. Anyway, this here should contain calcium chloride and probably some other impurities. So I'll be drying that out as well and see what I can get. Alright, so I've put the undissolved ash residue here on hot plate, and maybe I'll get that dried back to a powder. Meantime, I thought about taking a specific gravity reading of this solution just out of curiosity. Just as I suspected, it's very dense. Actually, it's off by scale. Specific gravity is more than 1.17. So, yeah. Alright, well, there's another way to measure density. So I measured out exactly 100 milliliters of the liquid, and I've zeroed out the scale. So I'll just measure the mass. So the hydrometer said it was a little more than 1.17, and it looks like it's actually 1.20. So that's pretty good agreement with the hydrometer. Okay, so I'll dry out what is presumed to be the calcium chloride using my electric skillet with a layer of sand in the bottom, and then this glass baking dish. Well, I finally got this dry in the beaker with a lot more difficulty than I expected. What I failed to take into consideration was the fact that it's heavily contaminated with calcium chloride now, and calcium chloride really does not like to give up its water, and when it does, it starts to get very hard. So I had to constantly keep stirring it and breaking it up as it got down to the point where it's almost dry. And then I did a test with a little bit of and added some more hydrochloric acid in. It showed that not all the carbonate has been reacted. It still needs to react with more acid. So I have no idea how much of this is calcium carbonate and how much of it's calcium chloride. But I'm going to do it a little different this time. I'm going to add some more acid, and then I will add quite a bit of water and try and wash all the chloride out of it. And what I eventually want to get down to is just whatever's left over that won't react with the hydrochloric acid. That's the goal with this beaker. The other liquid that I filtered off, which is presumed to be calcium chloride, is drying with much difficulty here in the skillet. And calcium chloride really doesn't want to give up its water. And like I said, if you're not careful, right at the end it'll just harden up into a solid chunk. So you need to be on top of it and start stirring it and breaking it up when that happens. And also I noticed that it looks, now that it's concentrated, it has sort of a greenish tinge to it, which is weird, and I don't know what that would be. Anyway, I prepared 50 milliliters more of HCl, so I'll just slowly add that, stir it in. That looks a little green too. This time I'm adding it to a dry powder. I really don't want to overshoot and have it acidic, but I don't know an easy way to tell. Obviously, if it stops bubbling, I've reacted all the carbonate. Reaction's obviously releasing a lot of heat, and along with the steam, it's carrying a little bit of the hydrogen chloride gas, which is sort of irritating. It's really interesting that sort of a greenish color. It's really strange. Maybe it indicates the presence of some iron contamination. I just don't know. Well, anyway, I'm going to add some more water to that. a strong suspicion now that I have excess acid at this point. Little test paper here. Yeah, it's gone acid on me. Probably have a lot of fun evaporating that. I probably won't. I'll just decant it off and dispose of it. But it should be at the point now where there's no more carbonate to react, so I'll probably filter that, and hopefully there won't be too much solid left. Well, it looks like I'll be running that through a filter again. It doesn't look very clean. Well, that's got most of the water out. I think I'll wash that with some clean water here, but first I need to empty this flask. Hopefully that'll get rid of most of the acid. Definitely not as much solid left now. It's still a fair amount. Well, that's about as dry as it's going to get by the filter, so definitely looks more gray than the first time I did this. So I think I'm just going to let this air dry. Hopefully all of the calcium chloride is removed now, so hopefully it'll dry rather well on its own. Yeah, I might give this another filter just to see if I can clean that up. So this time, in addition to the coffee filter, I placed a ball of cotton into the bottom of the funnel. I found that that works very good at filtering out particles from solution. I expect this should go very fast. Just turn on a little vacuum. It looks much clearer, but it still has a green tint. Just makes me wonder if that isn't iron chloride, or iron 2 chloride to be more exact, because that's what I have here in this jar. I think there might be a way to test that by adding a little hydrogen peroxide. Should be able to oxidize it to the iron 3 oxidation state. If that happens, it should be more of this color. So we'll try that later. Okay, after that filtering, it looks much clearer. I'm going to try and verify that the greenish coloration in the solution is caused by iron. So what I have here is, in this flask, is a little bit of hydrogen peroxide. So I'll pour out a little of the solution into this small beaker. Now I'll add a little peroxide and we'll look for a color change. If it's iron, as I suspect, it should go to a darker brown. I believe it did. It's more of an amber color now. See, the color is different. So that's probably iron chloride that went from the +2 oxidation state to the +3. Meanwhile, here's the powder that I was trying to dry that did not react with hydrochloric acid. It sat overnight, but it's still damp, so I'm going to apply some gentle heat to it and try and dry it further. Also, the calcium chloride that I had in the dish, I shut it down before it was completely dry, and then after it cooled down, it solidified. Upon applying some more heat this morning, it melted again, and I think it can exist in several different hydration states, and as you can see, it's in the melted state right now. So according to my research in Wikipedia, it can be in the hexahydrate state below 86 Fahrenheit, the tetrahydrate up to 113 degrees Fahrenheit, the dihydrate up to 347, and the monohydrate up to 500. So this may have been in the tetrahydrate, and it did start to melt around 100 degrees Fahrenheit or a little bit above. So That could be, I'm not sure if that means it's the hexahydrate or tetrahydrate, but I may let it cool down again and try and keep it broken up as it freezes, so I'll have a powder and not a big lump.